Hello my dear friends, welcome to this video. So formation of PDEs by eliminating the arbitrary functions. This is the hint for you. If there is only one arbitrary function, we get first order. More than one, we get the second order. It's clear? And there are some more interesting problems on it. Once the problem is given in the form of phi of u comma v equal to 0. What's the phi? Phi is only one arbitrary function. What about u and v? U and v are the functions of x, y, z. Even x, y, z means x, y, z. Yeah, because there is a function of x and y. That's right? There is a function of x and y. So maybe z is present or maybe not present. It's implicitly or explicitly, it doesn't matter. So how to eliminate the phi from, in the case of the problems looks like phi of u comma v equal to 0. Let us see the example. Before putting the example, how to eliminate the function phi from phi of u comma v equal to 0. Very simple concept. What about u and v? U and v are the arbitrary constants. U and v are the variables. It is in terms of x, y, or maybe it is z. Z is the presence. Is a function of x and y. We already know. So the elimination of phi from this phi of u comma v equal to 0 is very simple concept. It's nothing but already you know this concept. We can find out the j. Remember? Anyone? Do you remember the j? J of u comma v by j of x comma y. Anyone? What's the name of j? Jacobians. So what is Jacobian? It's nothing but dou of u comma v equal to 0. It is dou of u comma v by dou of x comma y. So here, while eliminating the arbitrary function phi from phi of u comma v equal to 0, is nothing but the Jacobian value is 0. Do you remember when the Jacobian value j becomes 0? Once the Jacobian value is 0, then we can say that both u and v are functionally related. So same concept here. The elimination of phi from phi of u comma v equal to 0 is nothing but dou u by dou x, dou u by dou y, dou v by dou x, and dou v by dou y equal to 0. Let us find the partial derivatives of u and v with respect to x and y. Put it in Jacobian with this 2 by determinant. We ultimately get the required partial differential equation free from the phi. So this is the idea behind this phi of u comma v equal to 0 model problems. Okay. So to see the example number 1, form the PDE or obtain the PDE from phi of x squared plus y squared comma y squared plus z squared is equal to 0. That's it. Obtain the PDE. That's it. We need the partial differential equation from this. So what is the meaning of this? If there are any arbitrary constants are there? No. What is it we have? We have arbitrary function phi. So this is looks like phi of u comma v model. Am I correct? Phi of u comma v model. Here what is u? What is v? Here u is equal to x squared plus y squared. What about v? V is y squared plus z squared. That's right. Right? Now find out the corresponding partial derivatives. Dou u by dou x is 2x. Dou u by dou y is 2y. So throw out this unit. What is z? What is z? Z be the function of x and y. So please always keep in that mind. Got it? Now what about dou v by dou x? Dou v by dou x, there is no x here, so 0. What about z squared? Z is a function of x and y, so z squared becomes 2z into dou z by dou x, otherwise 2z into p. Got it? What about dou v by dou y? Dou v by dou y is equal to y squared becomes 2y plus, once again z squared, z is a function of x and y, so z squared becomes 2z into dou z by dou y, otherwise 2y plus 2z cube. So once we got the partial derivatives, substitute in this form, what is it? when the given relation is the form phi of u comma v equal to 0, while eliminating the phi by putting the Jacobian value equal to 0, we will get the required partial differential equation. So this is the idea. Let us see, the substitute the values. So as we know that determinant of dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y equal to 0, which gives the required partial differential equation free from the arbitrary function phi. So let us substitute. What is dou u by dou x? It is 2x. Dou u by dou y is 2y. Dou v by dou x is 2zp. Dou v by dou y is 2y into 2zq is equal to 0. Already you know how to expand the 2 by 2 determinant. So cross multiplying diagonal wise. So 2 into x, it is 4, 2 into 4, 4xy plus 4xzq. Right sir? 2x into 2y is 4xy. 2x into 2, 4xzq minus 2y into 2zp. It is 4yzp is equal to 0. I think so. 4x, 4x, 4y. I think it's common, nothing was there. So what I suggest that first divide the root by 4. If I divide the root by 4, we get it is something like that. Here we have xy, here we have xz, here we have yz. So what I suggest you that, can you divide the root by 4xyz? What happened? This becomes 1 by z plus this becomes 4 will cancel. So q by y is equal to, this becomes next side, this is equal to, after cancelling the 4xyz, we get it is p by s. Right? So this is the required one. If you want to do the simplification, you can go for it, no problem. So if you do the simplification, we get some other answers like z is equal to qx plus py, right? Z is equal to qx plus py. So that is the another answer for this. Okay. So this is, there is no phi, p and q are only plus 1. If you simplify this, we get qx, it is py. So py minus qx is equal to, let us cross multiply this, we get it is xy by z. So that is maybe the answer. So by this way, can we take the what is it, yz, before that 1 by z. 1 by z is equal to xy is the LCM, xy is the LCM, so qx minus I. So it is py minus qx. Let us cross multiply this, we get xy by z. So otherwise it is py minus qx is equal to xy by z. Otherwise multiplying z to the next side, you get z into py minus qx equal to xy. That is also the correct answer. In the case is p into yz minus q into xz is equal to xy. That is also the correct answer. So we can do the simplification as you like, but if the given relationship is looks like the form phi of u comma v model, then Jacobian is equal to 0 is the only technique. Okay, and I have another idea in my mind. Can we apply this for any functions or any problems under the arbitrary function 1? Yeah, we can do. Let us see that. See this equation. Let us see the second sum. See the second sum. Suppose the question is obtain the PDE from z is equal to xy plus a function of x squared plus y squared plus z squared. See that this is the given relationship between x, y, z in terms of arbitrary function. How many functions are there? Only one. Z is equal to xy plus f of x squared plus y squared plus z squared. Is it possible to rewrite this into the phi of u comma v model? Yeah, we can do. How? Let us see that. This can be as z minus xy is equal to f of x squared plus y squared plus z squared. Right? Is it sir? And this step can be done as is a function of z minus xy comma x squared plus y squared plus z squared is equal to 0. So this is the another way to represent the given in terms of phi of u comma v model. So here also repeat this, z minus xy is one term and a function of x squared plus y squared plus z is second term. So this is my u, this is my v. So this is a function of two terms. So one is u. What about u, sir? Here u is z minus xy. What about v? V is x squared plus y squared plus z squared. X squared plus y squared plus z squared. We already know z be the function of x and y. Let us find out the partial derivative. So dou u by dou x equal to, what is dou z by dou x? P minus x becomes 1, so what is y? What about dou u by dou y? Dou u by dou y is z with respect to y is q minus x becomes a constant, y becomes 1, so q minus x. Similarly, find out the partial derivatives of v. So dou v by dou x is equal to x squared becomes 2x plus, there is no x, so it's 0. And what is z square differentiation? 2z into dou z by dou x or p. What about dou v by dou y? Dou v by dou y, no y here, the first term 0. Y squared becomes 2y and z squared becomes, with respect to y, 2z into dou z by dou y, otherwise 2z into q. Now the same idea, let us substitute this in the 2 by 2 determinant at Jacobian value. So Jacobian p minus y, q minus x, and 2x plus 2zp, 2y plus 2zq is equal to 0. So cross multiplying this, let us simplify, we get the answer. So the simplification is based on your individual quotient. You can do by any techniques, but it's a free from 5. What about p and q, sir? P and q are the first order partial derivatives, so we will get the required PDE. So let us see how to simplify this one. P minus y into 2 taken outside, so 2 into y plus zq minus of q minus x into 2 taken outside, x plus zp is equal to 0. Now divide throughout by 2. Divide throughout by 2, so this to be cancelled. That's okay. Let us multiply this one, you get the py. Multiply p into this minus plus zpq. Then y into y minus y square. Then minus yzq minus of q into x is qx. Q into this plus zpq minus x square minus x zp is equal to 0. The beginning of the term we have minus sign. So let us see that py plus zpq minus y square minus yzq minus qx minus zpq plus x square plus xzp is equal to 0. I think so. Plus zpq minus zpq will cancel. Any other term get cancel? Any other term get cancel apart from this one? Any other term get cancel apart from this? Can you see? Yeah, let us grouping the terms. P, here also P. Can I take the P first? Then we get this small y, then there plus x is there. Then next I go for the Q. So Q, this is also Q. Can I take the minus Q outside? The balance is x plus yz. That's right? See that I can take minus Q outside. What of the balance? The balance is minus y squared plus x squared. I can move these terms from the left hand side to right hand side. This becomes y squared minus x squared. That's it. So this is the required partial differential equation of order 1 in the form of phi of u comma v equal to 0. Even though the given problem is any function, we can try to convert in this phi of u comma v equal to 0.